So I was invited to join you today to tell you a little bit about myself, but mostly about this program that I help run, the Teen Research Internship Program. So this is a pretty cool program that all of you are invited to apply for, and you're welcome to ask me some questions at the end of my presentation, but Matt and Daniel can also answer your questions as they've both participated in this program in the past. So I will go ahead and get started because I want to be respectful of your time. We have about 15 to 20 minutes of me talking, and then I will be happy to answer questions and get to know you all. So my name is Dr. Leystra. I am education coordinator at Fox Chase Cancer Center. If you want to reach out to me at any time, you're welcome to do so. You can email me at my email address. If you have questions about this program specifically, it's probably better to use this email address because then either I will respond or someone else who helps manage the program can respond. And if you have a LinkedIn account, you're welcome to connect with me on LinkedIn. A little bit about me so you know where I'm coming from. I am a scientist. I did a bachelor's degree in biochemistry and microbiology. I completed a PhD in cancer biology and did some post-PhD research and training in gut health and cancer prevention. So if these are topics that interest you for some reason, or if you're thinking about going into any of these things, you are welcome to reach out to me and ask questions about them. As for what I actually do now, I was a research scientist and still do some research. As a research scientist, I spent time planning experiments and performing experiments, but a big part of a researcher's job is communicating the results of that research. So I spent a lot of time writing and talking about my science and reading papers by other people who were doing science so that I could make sure that my research was as up to date as possible, and lots and lots and lots of writing. So you may not think of a scientist as a writer, but that's actually probably one of the most important things that we do is write papers about our work and also write grants to get money to pay for our work. Now I spend most of my time as an educator, so I help build, coordinate, and teach programs for high schoolers, undergraduate students, graduate students, and people who have completed their PhDs. And I also educate the community about Fox Chase Cancer Center. So if you're interested in either of these career paths, feel free to reach out. But what I'm really passionate about, and what I think you'll find in a program like TRIP, is that I want to help students like you gain confidence in your future, whether that's to follow the same path that I followed or to find your own path. I want to help you be confident in that path that you're pursuing. And so in programs like TRIP, I really encourage constant questioning, asking questions that are important to you and exploring various possibilities in your future. And I also seek to teach transferable skills. So even though this is primarily a research program, you'll learn a lot of things that are important even if you don't end up doing research in the long term. And through this experience and others like it, I hope that you can identify careers that really match your skills, interests, and goals. Okay, so what is this program that I keep going on about? It's a research program that we host twice a year, once at William Tennant High School and once at Temple University. It's been going on for some number of years now, so we've really refined and improved it over time. And the program comes in sort of three phases. Early on in the program, you're really learning how to design a project and learning the tools you need in order to perform the research. And then partway through the program, you really start experimenting. So you design your own project, then you run the project. And then in the end, just like I said, a scientist needs to do, you're going to communicate the results of that work to an audience. And we really help teach you how to do each of these three phases of a research project. So through this program, students in the program learn how to ask questions, communicate about their results, and understand how their work fits into a larger picture. So we use the fruit fly as a model organism for all of our experiments, but we're not really interested in how what you're doing to the fruit fly affects the fruit fly, right? Well, nobody really cares about fruit flies. We want to help you fit your research into a bigger picture of human health. Through this process, you also get to practice thinking critically, solving problems, of which there will be many, I promise you, and learn how to fail forward when things don't work as expected. How do you get up and keep going? So like I said early on in the program, you're going to kind of identify a question that you're interested in and develop a project to test it. And a lot of students are intimidated by this when they first enter into the program. They have no idea what they want to study. But we really help narrow it down a little bit for you. So we use the fruit fly, like I said, as a model organism, and we can manipulate its environment. We can stress it out. We can feed it things, and then look at the outcomes. So there are a couple aspects of the fruit fly that we can look at. First, we can look at its overall development. So how fast does it grow? How fertile is it? How healthy is it? And this can give you a really good idea of how the things in your own environment or the things that you eat might impact how you personally are developing, whether it slows things down or is actively poisonous or maybe makes you more fit. But we can also look at a bunch of behavioral aspects of the fly. So flies, just like us, do all sorts of things. They need to eat, they need to sleep, they need to move around. They have circadian rhythms. So if they stay up all night studying for a test, that can really screw up how they're feeling the next day. They have moods, so they can be aggressive, they can be lonely, they can be depressed. And they need to learn and remember things. So we have assays for testing how well a fruit fly can remember a lesson. And to help people narrow in on what sorts of experiments they should be doing, we start by asking, what are you really interested in? So I just described some aspects of fruit fly biology, and I might ask you, are you really interested in these developmental processes, what you're currently going through? And if so, we have lots of ways to collect data on the development of the fly, so we can narrow in on the types of experiments you should be doing that way. Or maybe are you more interested, like I am, in studying like behavior and mood of flies, in which case we can look at movement, learning, mood, sensory perception, and we've got tons of experiments to do that. But even if we don't have exactly what you're looking for, we invite you to design your own little experiment to look at it. And we've had people do that. So I'll give an example of that in a minute. So really the program comes in sort of two phases. In the beginning, you learn how to use all of these tools and you do sort of an assigned project. But unlike school labs where you might have an assigned project, we don't know what the result of your project is going to be. And every student in the lab is doing a different project. So even though you don't get to pick what your question is, we don't know the answer. And that can be really, really exciting. But then in the second half of the program, you pick your own question, you design your own project, you collect your own data, and that's what you present at the end of the program. So one example of a student project that we had a couple of years ago now was from a student named Tyler. He was from William Tennant High School. At the time, he was a junior. Now he is a junior or sophomore at UPenn. And he was really interested in something that his family was doing. So his father was taking prebiotics on a daily basis and swore that this was really, really good for his health and was improving his overall fitness. And so he kept trying to get Tyler to take them too. And Tyler was a skeptic, so he wanted to test whether or not this prebiotic was really all that it was stacked up to be. So if you don't know, a prebiotic is something that is supposed to support the health of the bacteria in your intestines. And that in turn is supposed to support your overall health. So Tyler kind of tackled some of this flow chart that we had and said he was really interested in looking at how it would impact adults like his father, but how it also might impact developing individuals like himself. So he wanted to look at both adults and developing individuals, and he really wanted to look at how it impacted their overall physical energy and ability to move. But importantly, this prebiotic, like I said, is supposed to support the health of the bacteria in your gut. So he also wanted to look at whether it was doing what it claimed it was doing, changing the bacteria in the gut. And we didn't at the time have an experiment to look at that. So he helped develop his own experiment, which is called the microbiome assay, which allowed him to quantify the number of bacteria in the fly intestines. And so in order to do that, he really had to look at the adult animals as well as some developing animals. These are called larvae or maggots if you find them in your food, which is absolutely disgusting. So he used both of these animals to look at how far they could move, and then he focused on the adult animals to look at gut bacteria. And just really briefly, this is kind of cool because I would think it's cool. I helped develop it. The way this works, if you really want to see the bacteria from inside a fly, you have to make sure that first you sterilize the outside of the fly. So we sterilize the flies with ethanol. And that just kind of kills all the bacteria on the outside of the flies. And then we put them in a liquid that's effectively bacterial food. They really love the bacteria will grow very rapidly in it and crush up the flies to release the bacteria from inside the fly guts into this liquid. And then you can take that bacterial food and put it out on a bacterial plate and just count how many bacteria grow. So here's an example of one of these plates, and each of these little dots is a bacterial colony. So we dilute this out far enough that individual bacteria should be spread across the plate. And when those individual bacteria start to divide and grow, they eventually form what we call a colony, which is a whole pile of bacteria that originated from a single bacteria, and you can see it with the naked eye. So if you count the number of colonies, that tells you how many bacteria you put on the plate in the beginning. And then you can do a bunch of fancy math to back calculate based on the dilution how many bacteria were in the gut of the original fruit fly. So Tyler did this, and what he found was that in the flies that didn't take any of the prebiotic, there were a bunch of bacterial colonies, which you can see here. But as he increased the concentration of prebiotic that he gave the flies, he found fewer and fewer bacterial colonies formed. So this was the exact opposite of what he expected, right? He thought that the prebiotic would help increase the number of bacteria, but it looks like this particular prebiotic was not working the way it was intended. He also found that the flies had no change in their overall physical activity. So at the final symposium, he basically said, "See, Dad, you were wrong, haha," and he quite enjoyed it. So that's just one example of an experiment that students have done in this program. Both Matt and Daniel have done very different experiments. So Matt looked at fruit fly memory after spending lots of time in isolation, like many of us have done recently. And Daniel looked at the impact of inflammatory diseases on well-being and whether or not you can fight inflammation with poop transplants. So if you're interested in either of those projects, I recommend talking to Matt and Daniel. If this program sounds exciting to you, I invite you to apply. Just so you know, the program is in the spring from January through April. It's on Saturdays for 4 hours. And there's a lot of homework. So just come in expecting to do a bit extra work every week on top of what you're already doing. So if you're really, really excited about science and you want to spend half of your Saturday with me and a few other people from Fox Chase Cancer Center, this is your chance to do so. If you want to apply, our applications are open now on the TRIP Initiative website, and they're due on October 25th, which may feel forever away, but the application's actually quite involved. There are a number of essay questions that you're really going to want to draft your answers in advance and revise them several times, and you need to get letters of recommendation. So if you're interested, check out our website now and start working on your application so that it can be really, really strong. All right, I've talked for a while now. I'm kind of sick of listening to myself, so I would like to spend some time answering any questions that you have, either about my career and past or about this program. So ask away.
Thank you, Dr. Leystra. Let's all give her a round of applause. If anyone has any questions, feel free to just shout it from where you are or come up to the front and, give a quick introduction, give your name, and then state your question. But feel free to ask as many questions as you want, because something that we learned actually in TRIP is that if a speaker gives a presentation and there are no or few questions about what they said after they presented, it means that they did a bad job. It means that they didn't give a good presentation because people didn't understand what they were talking about. So asking questions is really valuable. So we highly encourage you to do that. So
Matt, before you get started, one thing, we're gonna have to volley back and forth. So obviously you're gonna unmute when they ask a question, and then whenever Dr. Leystra starts answering, try to mute, and I'll try this. Otherwise, it's gonna sound crazy. Yeah. So we'll try our best to make this for you.
Okay.
All right. Hi, I'm Shanisha. It's really nice to meet you. I wanted to ask, how did you first know that this was the career path you wanted to go on?
Yeah, that's a really good question. And honestly, it's a question that I think all of you are probably facing right now is how do you know what's the path for you? So I kind of described two careers, right? There's the scientist career and there's also the education career. And I can answer for both of those careers. So when I was in middle school, I think, I read a book called Jurassic Park, which I imagine you've heard of. And it's a book about how science, when used improperly, can cause devastating things to happen. But I thought it was really cool. Like the way that the author, Michael Crichton, described science, I was just fascinated by it. And I've always enjoyed solving mysteries. And science is actually just about solving a bunch of really big mysteries about our world. So I decided then I wanted to be a scientist. I didn't know what that meant, really, but I decided that's what I wanted to do. And in high school, I took a lot of classes, and my favorite classes were biology and chemistry. So I thought, why don't I study biology and chemistry? And then I saw that the school I wanted to go to had a degree called biochemistry. And I had no idea what that was, but it included biology and chemistry. So I was like, yes, that's what I'm going to do. So I did that. It turns out that just because you like a class doesn't mean you're actually going to like the work that involves the material. Learning concepts is not the same as working in the field. So it turns out I didn't really like biochemistry. I liked learning about biochemistry, but I did not like doing biochemistry. However, I did really enjoy microbiology and biology, both the labs and the classes. So when a professor told me I should apply to grad school and then told me that's how you become a scientist, I said, sure. So I did. When you go to grad school, you work for a while in a lab. As a biology graduate student, you actually don't pay tuition, and they pay you a stipend so that you can survive and do the work. And it's a couple classes for a couple years, but it's mostly full-time work in a laboratory. And I really enjoyed it. So I knew that science was the right path for me. When you finish a PhD, you generally cannot just get a job. You have to go do some additional training called a postdoc, which I didn't realize when I started grad school, or I might not have done it. But the postdoc is an opportunity to learn another field. So you become an expert in multiple fields. And I did that at Fox Chase Cancer Center, and I loved that too. But throughout this entire time, I spent about 10 years doing laboratory work as a graduate student and a postdoc, I was also always mentoring and teaching, because I knew that most laboratory scientists in colleges have students in the lab, and mentoring is an important aspect of what they do. And I realized partway through my postdoc that the time I was spending at the bench actually doing the science, moving liquids around and trying to discover things, was fine. But the thing that got me excited to get up in the morning and made it possible for me to do that work was the teaching that I was doing at the same time. So I realized that teaching was what I was actually really excited about. And so I sort of shifted and became a part-time scientist and a part-time educator. And now I've shifted more and more towards full-time education. So that's a long answer. The short answer is really just get out there and do things, like try them, not just learn about them, because the process of doing can help you realize what things you're good at and what things actually get you excited. And even if you end up changing your mind partway down a career path, it's okay. You've got lots of time, and people change paths all the time.
Thank you.
Dr. Leystra, something that you mentioned about how there's a lot of transferable skills in TRIP, like how even though you might not like research, what are some other skills that people build from doing this program?
Yeah, absolutely. So one of the big things that people get out of the program is just meeting more people who are passionate about similar things as them. And obviously, you're all in a club where you get to hang out with other people who like the same stuff. So that's a great start. But this also introduces you to people from a bunch of backgrounds you maybe have never encountered before, and certainly from other places that you probably haven't interacted with as much, since it's a regional program with students from many, many different schools, some of which are very far away. So networking is a big part of it. And sometimes those students go on to like room together in college. You also become part of a network of students who are already in college. So if you're interested in the school they're going to, you're welcome to reach out to any of our alumni and ask them, like, what's it like there? But bigger than that is really, I think, the communication skills. So we practice a lot of communication, just like nonchalant talking to each other, but also more formal writing and speaking. And it doesn't matter what you go into, being an effective communicator is really, really important. If you can't express yourself and share what you have found, nobody is going to know or care. And the last thing is problem solving. So you're all very successful and very, very smart, and probably haven't encountered many situations where you couldn't find a way to succeed or get a good grade. And inevitably, that's not going to keep being true throughout life. So in this program, I guarantee that you will fail at something at least once, but it's okay. There's no grades in this program. So we help you figure out how to overcome that and how to adapt when things don't go according to plan. Matt and Daniel, if there's anything else that you feel like you learned in the program, you're welcome to jump in and share that.
For me, I think the biggest takeaway from the program, as Dr. Leystra said, was the communication skills. Because in high school, I took a few English classes, gave a few presentations, but I never really thought of myself as being able to communicate scientific thought with a larger audience and community. And I was okay at public speaking. I wasn't the best at it, but definitely through this program, I was able to get better and better at public speaking, and hopefully that improved to the point where I can give presentations comfortably now to the club. So I think that was probably the biggest takeaway that I got from the program.
For me, I'd say it was a little bit more based in like creating things and developing things, because I came into the program and I was like, I know I like that, I like the sound of this, but I have absolutely no idea what I want to do or what my project should be. But as time went on, it really went like piece by piece. Okay, I don't want to do this. I don't want to do this. This seems cool, and you just slowly go further and further into it. And I to develop an experiment, but also more in general, just on how to work with other people to build something together.
Okay, another question is back here. Yeah.
Sorry, I couldn't hear the question. Can someone repeat it for me?
Dr. Leystra, in case that wasn't heard, the question was, how come you didn't like biochemistry, and what made you like microbiology? Yeah.
Oh, great question. So when I was learning biology and chemistry in the classroom, it felt like a lot of puzzles to solve. Like you learned a series of logic and then you applied it to questions on tests and assignments. And I liked that. I liked learning basic pieces of information and then applying them to solve a problem. When it came to actually doing biochemistry in a laboratory space, I found I wasn't very good at it. And I was still at the intro level, so I didn't get to do the fun stuff of trying to do the problem solving. It was basically just follow these listed steps and see what you get at the end, and it never worked for me. So that was probably more on me than it is on biochemistry. I also found that there was a lot more memorization involved than I expected, and I'm not a big fan of memorization. I'm not very good at it. Microbiology, on the other hand, was presented differently to me by my instructors. So a lot of it was the instruction. They did maintain, even in the labs, this sort of mystery problem solving approach to the science. So it was much more about, I think, how it was taught and my own personal talents and abilities than it was about the subject matter itself.
I have a question. Why do you focus on fruit flies? And also, a second question that I'm sure a lot of people have is, what's the cost of this program?
Those are great questions. So the first question, why do we focus on fruit flies, is sort of a historical thing. I did not create this program. I just run it now, but the person who created it was a fruit fly. Like that was what she used in her science. So it was a model she knew how to use. It's also a good way to model health in humans and is cheap and fast. So that's why we use it. The program is free. So it costs us money to run it, but it costs you nothing at all to participate.
That's a wonderful answer for that question.
Oh, God. Okay, well, we're wrapping up on time. Feel free to contact Dr. Leystra if you have any other questions about TRIP. Again, you can find it all on their website. Just Google TRIP Initiative, TRIP Initiative, and you'll find the website and how to contact the people in charge of it. But just a few notes about the program that I want to say, to advertise. It truly, I think, is an incredible program because, you got your programs offered by colleges, you pay $2,000, you do some kind of 5-day coding thing, and that's the end of the experience. For TRIP, first of all, it's free. Second of all, you spend January to April actually going in person to a lab setting for 4 hours a day to actually do your own independent research and do what actually interests you. And second of all, like Dr. Leystra said, there is a large alumni network because sure, you can go to a coding camp for 5 days and be done with it, but what comes next? What opportunities come from that? From this, you get networking, you can possibly get a letter of recommendation if you ask for one. Alumni can come back and actually review the next generation of students who apply and actually read and evaluate their applications. And some people even get asked to become teaching assistants or TA to actually go in and mentor and teach students after they completed the programs themselves. So this is an incredible opportunity for all of you. And if this is something that interests you, please feel free to ask me or Daniel any questions and check out their website and apply because due date's coming up soon, October 25th. And
one other angle too is, a lot of you are probably not sure what you want to do in the field of science, and you might think you want to go into research. I thought I wanted to be a physical therapist, and it took me going out into the field realizing I didn't great opportunity now to see, hey, do I like being in the lab? Is this an enjoyable experience? Because if you hate it, that'd be a good time to know that now, if you're trying to plan for that for the future. So it's such a great opportunity.
Yep, that's all very true. We've had a number of students, not many, like maybe one each program, who's like, I'm not doing research after they're done. And that's great. We're very excited to have helped you narrow down what you do and do not like. All right, thanks everyone. And I will ask Matt to share my contact info if you need it at any point.
All right. Thank you, Dr. Leystra.
Thank you.
Okay.